All right, let's jump right in. We're going to talk about a rule today, a rule so fundamental it runs our entire universe. I mean, everything from the biggest stars down to the tiny circuits in your phone. It's literally the engine of everything. And if you get this rule, you get a whole lot about our past, our present, and especially our future. So, what is it? What's this one single principle that connects a gigantic star, basically a nuclear reactor in space, with the smartphone right there in your hand? I mean, it sounds impossibly broad, right? But the answer? It's a single, super elegant, and totally unbreakable law of the cosmos. And that brings us right here to the unbreakable law of energy. This is the bedrock, the foundation for everything else we're going to talk about today. You gotta get this first. So, the answer, in just one word, it's energy. It's this invisible force behind, well, every action. It's why your car moves, it's why your phone can hold a charge, it's why your body is even working right now. You can think of it like the universal currency for just making stuff happen. But what's the actual rule that runs it? And here it is. This is the big one, the law of conservation of energy. It's got to be one of the most important ideas in all of physics. Energy cannot be created or destroyed, only transformed from one form to another. Just let that sink in. It means all the energy that has ever existed is still here, right now. So here's the key takeaway. The total amount of energy in the universe never, ever changes. It just puts on a new disguise, a different costume. Think about a bouncing ball, right? When you hold it up high, it's just loaded with potential energy, stored energy. Then as it falls, that potential energy transforms into kinetic energy. That's the energy of motion. And when it hits the ground, bam! It transforms again, this time into sound you can hear, and a little bit of heat. The energy keeps changing its form, its disguise, but the total amount, it's always, always the same. Okay, so let's zoom out, way out, from a single bouncing ball to our entire planet. Because humanity, well, we took this principle of energy transformation and we used it to build our entire modern world. You could say we're pretty addicted to transforming energy. And for a long time, our main fix, our main source, has been fossil fuels. And man, have they taken an incredible journey. You know, the energy we release when we burn coal or gas today, it's actually ancient sunlight. No, really, it was captured by plants millions of years ago through photosynthesis. Over these immense stretches of time, all that plant matter just packed with stored chemical energy from the sun got squished and cooked into the fuels we use now. It's wild to think about. We are literally running our world on prehistoric sunshine. Now, this whole reliance on ancient sunshine, it forces us to make a really critical distinction. On one side, you have non-renewable sources. That's the fossil fuels, which are finite. There's only so much, and they take millions of years to form. And on the other side, you've got renewable sources, like solar and wind, which, get replenished on a human timescale. The sun comes up every day, the wind blows. For a very long time, we've put almost all our bets on the finite kind.
And that reliance? It's come with a pretty massive consequence. All that energy transformation has had a planetary-sized side effect. So let's talk about the planet's rising fever.
But first, just a real quick but super important clarification. We need to be clear on the difference between weather and climate. Weather is what you get day to day. A rainy Tuesday, a sunny Wednesday, it's what you get. Climate, on the other hand, is the long-term pattern. It's what you expect over years and decades. And that's what's changing. So here's what's happening. The Earth has this natural greenhouse effect that keeps it, warm enough for us to live here. It's a good thing. But by burning all these fossil fuels, we're pumping enormous amounts of extra greenhouse gases into the atmosphere. And those gases act like an extra blanket wrapped around the planet, trapping more heat and making that natural effect way more intense. We've kind of thrown the whole system out of balance. And what's the result of that imbalance? Well, so far, the average global temperature has already climbed by about 1.1 degrees Celsius since before the industrial era. Now, I know what you're thinking. 1 degree? That doesn't sound like much, right? But for a huge, complex planetary system, that's a serious fever. And the consequences of that fever, they're spreading all over the globe. It's way more than just things getting a little warmer. It's fueling more frequent and way more intense weather. We're talking brutal heat waves, devastating storms, you name it. And at the same time, it's actually changing the chemistry of our oceans, making them more acidic. This causes this massive, massive disruption to ecosystems all around the world. Okay, so that's the diagnosis. It's a big one. The question now is, how on earth do we respond to a challenge this monumental? Humanity's strategy, really, it boils down to a two-pronged attack. On one side, we've got mitigation. That's all about tackling the cause, doing whatever we can to reduce our greenhouse gas emissions. Then, on the other side, there's adaptation, and that's about living with the effects that are already here or are unavoidable. It means adjusting our societies to handle the changes that are already happening. And let's be totally clear here, this is a challenge on an epic scale. I mean, it requires a fundamental rewiring of our entire global energy system. This is absolutely one of the greatest, if not the greatest, engineering challenge humanity has ever faced. But engineers, they live for challenges like this. So let's look at how we're starting to engineer a greener future, using the very same laws of physics that got us into this mess in the first place. And this is where it all comes full circle. We're applying that exact same law of energy transformation, but this time with a whole lot of ingenuity. We're getting crazy good at transforming the sun's radiant energy directly into electricity with these hyper-efficient solar cells. We're transforming the kinetic energy of the wind into power on a massive scale, with offshore wind farms whose turbines are as tall as skyscrapers. And this is the really critical piece. We're finally cracking the code on how to store all that power as chemical energy in advanced grid-scale batteries. See? It's the same law. We're just using it for a smarter, cleaner transformation. But look, this isn't just a story about giant turbines and big global policies. It's also a story about you, about me, about individuals. So let's talk about your role in this whole transformation. We all have something called an energy footprint. What is that? It's basically the measure of all the energy you consume, both directly and indirectly in your daily life. Every time you flick on a light switch, every mile you travel, it all adds up. It's all part of your footprint. And if you look at a typical household, this is where most of that energy goes. A huge chunk of it is just for heating and cooling our homes. After that comes our appliances, then lighting, and of course, all our electronics. Just understanding this breakdown helps us see where we can make the most impactful changes in our own lives. The real takeaway here is actually pretty simple, but it's also incredibly powerful. You're not just a spectator in all of this. Every single time you use energy, you are an active participant in this huge global story of transformation. And that leaves us with one final thought. Remember where we started with that unbreakable law of physics. Energy can't be created or destroyed, it only transforms. The energy itself is constant. But you know what isn't? Our future. So the real question is, how will you transform it?